Welcome to the YouTube channel PCMB Tutorials. I hope you all are fine. Today we are going to learn Class 9th Chemistry Chapter Periodic Classification Part 10. So in this part we are going to learn many revising things and new things too. So our first thing is bird's eye view of the evolution of periodic arrangement means the revision of all the discoveries of most famous scientists. First scientist was Lavoisier. His contribution was metals and non-metals. Then was Dalton. His contribution was atomic theory. Third was Prout. His contribution was atomic mass of every atom of an element is an exact integer multiple of mass of hydrogen atom. Contribution of Berzelius was symbols of atoms. Doberiner's contribution was grouping of elements into triads. Dumas' contribution was arrangement of elements as a homologous series. Dech and Cortius' contribution was spiral helix arrangement. Newland's contribution was law of octaves. Odling's contribution was arranging similar elements into vertical columns. Lothermeyer's contribution was atomic volume curve. Mendeleev's contribution was first periodic law and periodic table based on atomic weights. Moseley's contribution was modern periodic law based on atomic number. Bohr's contribution was long form of periodic table based on electronic configuration. Then main topic is periodicity. Our today's main topic is periodicity. Which means the repetition of at regular intervals of properties of elements in a periodic table is called periodicity. I will repeat. The repetition at regular intervals of properties of elements in a periodic table is called periodicity. So, doubt is that what causes periodicity? What causes? So the properties of elements are governed by electrons in the outermost shell of the outer electronic configuration. The outer electronic configuration gets repeated at frequent intervals and hence the properties also get repeated. For example, lithium has one electron in its outermost shell, that is 2, 1. So after a few elements, again a similar configuration, same number of outermost electrons appears for sodium 2, 8, 1. Then once again after a few elements the same configuration gets repeated for potassium 2, 8, 1. This happens for few more elements like rubidium and cesium. As the electronic configuration of the elements is repeated, so also their properties lithium, sodium, potassium, rubidium, cesium gets repeated. So we can conclude that properties of elements get repeated at regular intervals due to repetition of outer configuration causing periodicity. Then periodic properties. So the properties that undergo variation with the change in atomic number within a period or a group are known as periodic properties. The main periodic properties are atomic size, ionization, potential, electron affinity, electropositivity, electronegativity, and valency. Let us discuss few of them. First is atomic size or size of atom. Atomic size or size of atom. It means the size of atom is indicated in terms of radius of an atom. That is the distance from the center of nucleus to the outermost orbit. I will repeat. The size of the atom is indicated in terms of radius of an atom. That is the distance from the center of the nucleus to the outermost orbit. Then units. The radius of an atom is measured in terms of angstrom units, where 1 angstrom unit is equal to 10 raised to minus 8 centimeter or 10 raised to minus 10 centimeter. This is nucleus radius, and this is the nucleus. After that, there is variation of atomic size in a group. Variation of atomic size in a group. To understand the variation, there should be the electronic configuration of the outer shells of elements in a group of first A. The outer cell configuration and their outer shell from 1A group, I will say the outer shell configuration. So this is of first A group. Hydrogen, lithium, sodium, potassium, RbCsFr. Rb is rubidium, Cs is cesium, and Fr is francium. Their outer shells are 1, 2, 3, 4, 5, 6, 7 respectively. But having one electron in the last shell. On moving down the group, new shells are added and outermost number increases. So the distance from the nucleus to the most orbit increases. Atomic size increases. Therefore, as we move down the group, the atomic size increases I'll repeat, as we move down the group, the atomic size increases. I hope you have understood till this part 10. For any queries and doubt, please join the Telegram link given in the description of this video. In part 11, we will learn the further points, that is variation of atomic size in a period, then exception, then the smallest and biggest atom, then we will learn the atomic size and its correlation with group number and period number. Then we will learn the comparative size of ions, then size of cation and anion, cation and anion. Till that, I hope you have understood this part. Like, this is the foundation of class 9th. We have covered the foundation of class 8th and 7th too. The links are given in the description. Please go and check through it. I hope you have understood till this. Thank you for watching. Let's meet in 11th part.